everyone. In last lecture, we have discussed the definition of signal and system. In this lecture, we will discuss the classification of signals. It includes deterministic signal and random signal, continuous time signal and discrete time signal, periodic signal and non-periodic signal, energy signal and power signal. First, we'll discuss the deterministic signal and random signal. The deterministic signal is a signal about which there is no uncertainty to its value at any time. These are deterministic signals. The random signal is a signal about which there is uncertainty before it occurs. These are random signals. Discussion. Are these signals in the practical applications, such as ECG signals and audio signals, are generally deterministic signals or random signals? Now we'll discuss the continuous time signal and discrete time signal. The continuous time signal is defined for all time t. It is represented as x of t. T can be any real number. T is a continuous variable, and there may exist finite discontinuous points. The discrete time signal is defined only at discrete instants of time. It is represented as x of k. K can be any integer number. Relationship between the continuous time signals and the discrete time signals. By sampling, we can convert the continuous time signals into discrete time signals. Now we'll discuss the periodic signals and non-periodic signals. For continuous time periodic signal x of t, if x of t, a function of time, satisfies the condition for all t, where t is a positive constant. If this condition is satisfied for t equals t0, then it's also satisfied for t equals 2 times t0, 3 times t0. The smallest positive value, t, is termed as the fundamental period of x of t. The fundamental frequency and the angular frequency of x of t are defined as in this equation. This is a periodic signal of rectangular wave. This is a periodic signal of triangular wave. For the discrete time periodic signal x of k, if the discrete time signal x of k satisfies the condition for all integer k, when n is a positive integer, the smallest positive integer n is termed as the fundamental period of x of k. The fundamental angular frequency of x of k is defined as in this equation. For example, this is a discrete rectangular wave. Its period n equals 20. This is a discrete triangular wave. Its period n equals 10. Non-periodic signal. Any signal x of t for which no value of t satisfies the periodic condition is termed as non-periodic signal. For example, these signals are not periodic signal. any signal x of k for which no value of n satisfies the periodic condition is termed as non-periodic signal, such as this signal. Here is the tuning forks. They can generate the periodic signals. For example, let's listen to this. Let's listen to this. For example, this sine signal, a periodic signal, if we can find the t, this t, the signal can be periodic signal. For sine function, if this equation can be satisfied, this condition should be satisfied. So, if sine function is a periodic signal, therefore, for a continuous time sine signal, it's always a periodic signal. Its period t equals 2 times pi over omega 0. This signal x of k is a periodic signal. Similarly, if there exists this equation, if we can find the n, the signal is a periodic signal. If we cannot find the n, the signal is not a periodic signal. According to the property of sine function, we can get this equation. If the omega 0 satisfies this equation, the signal is a periodic signal. So, sine omega 0 k may be a periodic signal only if omega 0 over 2 times pi can be represented as a rational number. Therefore, discrete time sine signal may be periodic signal. For example, the signal is a periodic signal. If yes, find its period n. Its angular frequency omega 0 equals pi over 3. According to this value, we can get this equation. Because this is a rational number, so this sine of this sine function is a periodic signal. Its period equals 6. If there are no common factors between n and m, its periodic for sine function equals n. Now we'll discuss the energy signal and the power signal. First, we give the definition for the energy and the power. The energy E is defined in this equation. The power is defined in this equation. For discrete time signal, its energy and power are defined as in these equations. A signal is termed as an energy signal if and only if its energy E satisfies the condition, and its power should be 0. A signal is termed as a power signal if and only if its power P satisfies the condition. The power should be a finite value. The E should be infinite. These are energy signals because their energy E are finite and its power equals 0. These signals are power signals because their power P are finite and their energies are infinite. For example, determine the energy and power of signal x of t. Here, A doesn't equal 0. This signal is a periodic signal, and its fundamental period is 2 pi over omega 0. Obviously, the energy E0 in one period is calculated in this equation. As there are infinite periods for this periodic signal, the energy E of the periodic signal x of t is infinite. The power P of the periodic signal x of t is calculated as in this value. So the signal is a power signal. Its energy is infinite, and its power is finite. Here is another example. Categorize the signal x of t equals 2 as an energy signal or a power signal. For the direct current signal, its energy E is calculated in this equation. It's infinite. Its power P of the direct current signal is calculated in this equation. Its power is finite. The energy E is infinite, and its power P is a positive number. Therefore, the direct current signal x of t is a power signal. All the periodic signals and the direct current signals are power signals. Here is another example. Categorize the signal as an energy signal or a power signal. Its energy can be calculated in this equation. It's infinite. Its power P of the signal is calculated in this equation. The energy and the power are both infinite, so the signal is not an energy signal, neither a power signal. In this lecture, we have discussed the classification of signals. It includes deterministic signal and random signal, continuous time signal and discrete time signal, periodic signal and non-periodic signal, energy signal and power signal. In this course, we will not discuss the random signal. That's all for this lecture. See you later.